The paired design, often an excellent choice when it's applicable. Here I am at the data paired page of ESCI, and I'm looking at the Thomason 1 data set. So we have 12 participants, and here they are, 1 to 12, and for each one we have a pre-test and a post-test score on the LSAT. In the figure here I have the mean and 95% confidence interval for pre-tests and for post-tests. This line joining the means signals that the independent variable of pre-test post-test is a repeated measure. It signals that we have a paired design. Using such a line is a very useful convention to signal a repeated measure, but unfortunately we can't always rely on a repeated measure being signalled by such a line. And I can see a very short confidence interval over here on the difference axis, which is good news. If I click on Display Data Pairs here, I can see the raw data for all 12 participants, and they're linked by lines, as they have to be because they're actually paired. And the differences, I click here and I have differences. Well, there must be some overlaid ones there. Let me offset them. There we go. And so these joined up blue circles give us the pre-test and post-test, with each line representing a separate participant, and each one corresponding to one of these triangles which indicate the difference, the gain score, the post-test minus pre-test value for each individual participant, plotted on this difference axis. Now most of the participants show a small to medium increase from pre-test to post-test. Just one shows a decrease, and I can highlight these. Let's highlight participant number 1. Went from this pre-test to that post-test, an increase of 1, and there is that participant's difference score. Let's participant number 7, for example, the one that made a decrease, represented by this single negative difference. In fact, just down 1 point from pre-test to post-test. Our research question is, to what extent are post-test scores different from pre-test? To what extent did the argument mapping treatment lead to an increase in test scores? And so I'm interested in these gain scores represented by these triangles. And the mean of all those is this pink triangle here on this difference axis, and shows us that on average, gain was about almost 2 points. And the confidence interval on that gain was really quite short. Notice the big contrast with the independent group's design. With independent groups, independent confidence intervals, the confidence interval on the difference is always a little longer than these confidence intervals. But for the paired design, we can have, not guaranteed, but we can often have a short confidence interval on this difference. And this difference, this mean of all these differences, which is the same as the difference between the post-test mean and the pre-test mean, that's the effect size we need to answer our research question. And the confidence interval on that will be short if these differences are fairly consistent, if they don't vary too much, because this confidence interval is based on the standard deviation of all these differences. If we have a pattern of these lines being all fairly similar, here mainly increasing just a little bit, this corresponds to these differences being fairly tightly clumped, the standard deviation of the differences being quite small, and so this confidence interval is quite short, and that's excellent news. Over here we have the summary statistics for the pre-test, for the post-test, and down here for the differences. So the mean difference here is about 1.7, which is shown here by the triangle on the difference axis. And the standard deviation of the differences, about 1.4, 1.5 there, is distinctly smaller than the standard deviation S1 and S2. 3.3 and 2.9 for the pre-tests and post-tests. Another way of saying the same thing is that if there's a high correlation between pre-tests and post-tests, well, we're not up to correlation yet, that's in Chapter 11, but broadly it refers to the situation where those students who score high on pre-test tend to score high on post-test. Those who tend to score low on pre-test tend to score low on post-test. That's a high positive correlation between pre-test and post-test. And in fact, here the correlation is 0.89, very high positive correlation, given that the maximum is 1. And that corresponds with these differences being tightly clumped and a short confidence interval on our effect size. As in quite a few ESCI pages, if I scroll out to the right, I've got several data sets here, Thomason 1, 2 and 3, and note that they have different measures, LSAT, LSAT and the HCTA. Do you feel a meta-analysis coming on if we want to combine these results? I could, for example, click here for the Thomason 2 data set and transfer them left, and there they are. Once again, we have a relatively short confidence interval on the difference, the difference scores fairly closely bunched, and a correlation as high as 0.87, indicating once again we have a sensitive design. So that's the paired design. When it applies, when we can use it, it's often sensitive and a very good choice. But we have to watch out for carryover effects, for some influence of the first measurement on the second measurement. But when we can use it, it often gives us a relatively precise answer to our research questions, which makes us very happy.